Hello everyone, this is Mandeep Singh 𝐒𝐿 and it's been quite a time since I last published my video and I was quite busy with other things, you can say like office work or any other things or interest I was pursuing, but it's been quite a time and I wanted to get back to YouTube and wanted to publish some of the videos and like whatever I was learning. And this is one of the problem statement which we will be discussing today, which is live comment system. I will get more into this, like what this actually mean and what we are trying to solve. So as I mentioned, right, I was pursuing other interests. So one of the areas which I was working was that I was working on a book basically. So if you follow me on LinkedIn regularly, you might have seen multiple posts about system design on AWS. This is like still not in the physical copy yet. You can still read the early release chapters on the O'Reilly platform. You can find the all the early release chapters there. Like not all chapters are released yet, but in the early release format, some of the chapters are included there. And if you have subscription, or you can get the 10-day free trial and read the book there. And any feedback is appreciated. The book is set to launch in February next year, so very excited about it. But yeah, so one of the chapters was like designing newsfeed system or social media platform, right? So in those kind of systems, this is one of the problems. One of the features, you can say, that users publish content regularly, or you can say posts, right? On Instagram you post, you publish a photo, okay, you publish a video, and these problems become prominent in case of live streaming videos, okay. So what we are trying to achieve is, we are trying to achieve that whenever a post is published, if there are any new comments, and this mostly happens for the celebrity users, like let's say a lot of followers or a lot of users are following a particular user and the post is published by that user. So in that case, lot of people will come and post the comments, okay, and there will be lot more people who will read those comments. So what you want to do is like everyone who is looking at that content at that moment, you want to show whatever comments are published on that to all the users who are reading that post. And this holds true for any of the live streaming video which I mentioned, right? So one of the use cases that there are regular reactions which keeps on happening on those videos. Like let's say you liked, you heart, वो ऐसे like there are a lot of hearts popping out of the video. So those kind of reactions you want to deliver to all the users in real time. So that is the problem we are trying to solve. It's a generic problem statement, like yeah. So let's directly get into it. We will not discuss too much into the initial thoughts of it. So if I, as I explained already, right, and I have created notes for this just so that I don't forget, as it's been quite a time since I last created my video. But and this video I'm trying to create in completely in English. Yeah. But the requirements per se, we mentioned that users post a comment or there is a live streaming video going on. You want to deliver those comments in real time to all the users who are looking at that post, okay. So that is one of the thing. Then there are type of comments, what kind of comments you can publish. We are focusing that you can say that only Unicode characters, like let's say, so that you can also show the reactions which are happening. So textual comments basically, not the ASCII but Unicode characters basically, okay. There are different multiple additional features which we are not discussing in this video, but yeah, there are a lot of things which you can imagine. The gamification is the big part of these kind of systems, okay. So whenever you are providing this kind of experience, what you want to gamify the experience and earn some money out of it. So that's the case. If we talk about NFR, so NFR, first one is latency sensitive. When I say latency sensitive, so all the users who are publishing the comments, all the users who are publishing the comments, and there are a lot more users who are actually viewing those comments. And whenever I say comments, assume that any similar analogy to it, okay. Let's say there are reactions going out or there are comments being published. So any of those scenarios, you want to be you want your system to send them out immediately as soon as possible. Near real-time behavior we already mentioned. So our operation, or like you can say our system, is latency sensitive. Another thing is our system should be scalable. So these are like generic NFR system, NFR or non-functional requirement which we have mentioned and we want to achieve for our system. So, and the important one is eventual consistency. Now on the eventual consistency part, uh, it's hard to support strong consistency here. Okay, so that's one part. Supporting strong consistency hard, but the important what you can say consideration here is that we don't need that. We don't need strong consistency here. It's fine that if users like not users see that comment with a little lag, or you don't want to ensure that, let's say if 50 comments are being published or saved in our database, you want to show all the comments to all the users. So it's fine that if not all users see all the comments, but eventually they should be able to see all the comments. One of the thing which I want to mention here is, so if a user is publishing a comment, okay, so if a user is publishing a comment and the comment is being pushed to the system, or you can say saved to the system, that user should definitely be able to see that comment. Okay, so the user should not be confused if my comment is published or not. So that's basically read your write consistency, which you can say. So basically whoever user is writing that comment, that user basically should be always be able to see that comment. We might not be concerned about other users in case of eventual consistency, but the user who has written the comment should definitely see that comment, and there are different ways you can achieve that. Okay, uh, right now not going into that, but specifically sticking out to our main problem, which is you want to deliver these live comments. Okay, so that's another problem out of, and you can definitely read that in the book. But yeah, scale I have not included in numbers here. It's just that whatever like the number of what kind of operations you should know, that will help you to think around the design of the actual system. Okay, so you should definitely have that scale in mind to make proper assumptions while you design the system. But what you should know is what are the number of comments which are being published per second, and for celebrity users or for the large videos, large streaming videos, how many users are publishing the comments and how many users are reading the comments. So you should basically have that idea to get the estimations around uh, maybe your server capacity. Okay, how many connections are being established with your servers or backend systems, how will you manage the load. Okay, or definitely on the design choices as well, we will discuss on this in the next section, that this will definitely impact your design choice as well. Like whatever scale you are supporting, the scale is too less, you can directly make the call and fetch the comments. Okay, but that might not be prominent or a useful approach if there are a lot of users. Cool. uh, and this video which I have created right now is kind of inspired. I went through a lot of engineering blogs which are available, but kind of inspired by the FB engineering. It was quite old. I think it was from 2011. Yeah, it was 2011 blog. So, and at that time there were 100 million per minute for the comments which were being published comments which were published. Okay, so we are talking about huge scale. Now let me take a sip of water, and we will get started with the design. So on the design part, right, one of the thing which you one of the thing which you often come across is, like, you might have seen the how you design chat applications video on my channel, or like you might have read another blogs. It's a pretty popular problem, that how will you design systems such as chat applications, WhatsApp, Facebook Messenger, or any of the Telegram, any of the chat applications, how will you support that. Okay, so that is one of the problem statement, and we will try to relate with that problem statement here. Another statement is uh, how will you build a news feed. Okay, so in that case we generally discuss around problem statements, and again you will find both of the videos on my YouTube channel which are already published, that if you are publishing or you are pushing that feed out to the users, and if it's a celebrity user, how, what kind of mechanism you will follow, so that you are able to show all the posts which are created by that user to all his followers, all her followers, or whichever whoever the user is. Okay, so that comes to our important discussions here, push versus pull, and that's the most important discussion, and that's the crux of this problem, you can say. So before going into and again, as we said, right, it depends. And scale is the important consideration, that which is the most feasible approach here. So if we talk about pull mechanism is basically you have a user device. So I try to create the diagrams. Okay, here we are. So a user is publishing a comment. It's basically some of the backend service. It's directly, I have named it user post service. So a user publish a comment and then it is saved to database, and other users, I have shown only single user, but there are a lot of users here. All users who are trying to get the comments. Okay, so these comments are retrieved from the DB and then they are served to the end users. You might have your cache on top of your DB. uh, Different caching strategies, but you might be following one of them. But you, let's say you have a cache on top of it, so that you don't have to hit the database again and again for pulling the same comments if there are a lot of users. So this is the uh, I mean, what you can say, very simplest approach which you can take. And if there are number of users are less, you should directly consider this approach to start with. But as we said, right, we are talking about a little bit scale here. So in that case, and before moving to like I mean, we said that we are going to scale and all those things, we should know that what kind of problems this pull based approach can cause. So what are the problems? What are the problems problems Okay, so I created one video around polling and long polling. Okay, short polling or long polling and web sockets, something like that. So what you do is, in case of polling, what you do is you directly let's say you make the request, you get some response, or you don't get a response, then you again make a response, not a response, you again make a request and then you get a response. The response might be empty or you might receive some kind of data. Okay, so that's the thing. Another thing is long polling. So in that case, what happens is the servers holds that connection. Server holds on to that connection. That let's say if there is no response, or like let's say there are no new comments which are there in the server, then there are not there, like the connection is being hold off, unless let's say some threshold value, let's say 1 minute. And after that 1 minute or so, the connection is returned. If there is any response, then the comment, in this case the response are the number comments, newly published comments. If they are not, then empty response is returned and then the client establishes a new connection. So what kind of problems this can cause? The problems which can occur here are, one is, all the user devices are trying to fetch the data, and there is a high possibility that there is no data available at the moment. Or there is no comments being published by the users. So you are unnecessarily increasing the load to the server. Okay, how you are increasing the load? Because the requests are being hit continuously by lot of the user devices which you have to your servers to check on, right? Give me some new comments. Do you have any new comments? If there are any comments, give me to them. Give them to me. Okay, my English is little that bad, but so that's the problem. What you are trying to do is, let's say you have kept that 5-second window of to ensure that real time behavior. 5 seconds window is a little large if we consider near real time, but let's say you have considered 5-second window and you are trying to hit that server again and again if there is new data or not. If there is data, then yeah, show it to the user device. So that's the problem. The basic problem is that you are increasing the load to the server, and just think opposite to it. Okay, maybe in the direction that, do you actually need that? Can somehow the server know that if there are comments, the comments will be delivered to the user devices? So that's the kind of approach we want to take. So this is the push mechanism. Whenever push mechanism, what we mean is that whenever there are, what do you say, whenever there are new comments on the server or on the backend system, the comments will be pushed to the user device. And how they will be published? Okay, so to push, I like to make that connection from server to user devices. Okay, uh, if we talk about push mechanism, there are generally two ways. One is that you have callback endpoints, and we heavily use that in case of, let's say, service to service interactions. Okay, uh, basically for event driven architecture, you can say, or async processing, you can say that, let's say, your client made one request, and the client, if client made the request, uh, the request is acknowledged and a 200 response is sent, that I have received that request and I will send a response later once the processing is done. Okay, and that particular service has whitelisted of endpoint, and on that endpoint you deliver that response. Okay, so this is one of the way. Another way is that you build persistent connections with the user devices, and I said that earlier in this video itself, that we will try to relate our problem statement with the chat applications. How? In case of chat applications, we have discussed that we try to, or not try to, we actually do that. What we do, we establish a persistent connection with the user devices, so that you can deliver the messages from one user to another in a very latency sensitive way. Okay, uh, very minimal possible latency. Okay, so to do that, we have a persistent connection available. Whenever I say persistent basically means the connection is readily available. You don't have to spend time on establishing that connection. Okay, so you are basically what do you say, reducing the time to establish that connection. Okay, if it's a TCP connection, that you are avoiding that three-way handshake and all those. So there are different ways you can do that. I have noted some of them: WebSockets, SSE, gRPC, MQTT. Again, we will not go into each of these details. We will just assume for now that we have a persistent connection, and we have a dedicated chapter in our book as well, System Design on AWS. Again, you should see the cover of the cover of the book. You have a dedicated chapter in the book which talks about different protocols, communication protocols, and all these are included there, where you will understand how choosing a particular protocol is important while making a system or designing a system. Okay, so we have concluded that in our case, or like to solve our particular use case, push based approach is more useful. Now, how it will work? Let's go into the diagram. Here is our yep diagram. Can I somehow enlarge it? I'm not sure, but yeah, we can scroll. Yep. So again, just a sec. Now what we are trying to do is not we what users are trying to do is, a user publishes a comment to our, again, to the same backend service, and you can assume that it is horizontally scalable, and there is definitely a front end, a load balancer or router which is in place, which is routing the request to this service. Okay, so a user publishes a comment, user post service, it is being saved to the database. Once it is saved to the database, in push based approach, what we did was, the same database was used to retrieve the comments for all the request, all the get request which we were having. So basically we are updating this read flow. The write flow is still the same, we are updating the read flow. Okay, so what we are new, like what is being newly done in case of read flow. So in this case, whatever entry which is being written to the database, whatever entry that is being written to the database, it is sent to a queue. Okay, queue, and like all the changes, CDC means change data capture. So whatever updates which are specific to the updates, uh, which are specific to the comments. So for any particular post ID, if any new comments are added, okay, if any new comments are added, then those changes are propagated to the queue, and then it's they are sent further for the for further consumption, so that they can be delivered to the end users who are interested in this particular video or post. Now let's take a pause on this flow here. Let's quickly discuss around how you readers are connected, how users are connected. Okay, so let's say that a live streaming video is going on. Okay, so if live streaming video is going on, a user is watching a video. Now whenever a user is watching a video and you assume that a user is authenticated and all those things are happened, now we are just focused on this particular delivery of these events to the users. Okay, so let's say a user is watching the event, you are watching a cricket match. Cool. So whenever a user is watching that, we establish a persistent connection with that user. Okay, you establish a persistent connection to that user, and it is, I'm not going into much details how this will work. We already have discussed this as part of our WhatsApp system design discussion. But you can, what you can say is that let's say a user is interested in video 1 and video 2. Okay, so what I will do is I will create entries in my system. Basically you can say a simple hash table. Okay, or you can say just a mapping table. So this particular user is interested in uh, video 1 and video 2. Okay, and the mappings are stored in reverse way, so in a way that video 1 is video 1 is subscribed to user 1 and user 2, so that that mapping is useful whenever those events come. Okay, so you basically have mapping of video 1 to user 1 and user 2, viewer 1 and viewer 2. Now coming back to this, whenever a notification, whenever a comment is published, this is saved to the queue. This is being consumed, so you have a lot of consumers which receive these events, and once these events are consumed, they are being forwarded to the our gateway service, connection management service, where all users are connected. This basically like the event, the simplest event could look like you have post id. Okay, and the content of the comment. Okay, so for the particular post, you have the content comments. Now this will check that for this particular post or for this particular video, who all users are interested, to all the users this comment is forwarded. Okay, cool. So this is the simplest flow, and I think you got the idea how this is happening. Cool. And this is expanded to multiple reasons actually, right? If we talk about like scale of Facebook or scale of Instagram or whatever large scale application we are talking about, you can assume that application is deployed into multiple regions, and due to the same reason, like we want our users to be connected easily to their home region. Or let's say if I'm in India, right, let's say an application is deployed in Mumbai for AWS region. If we have deployed in Mumbai, so the users are connected to that region and those comments are published to that region. This checks that for this particular video, all the like who all viewers are interested, and all the viewers who are interested, that comment is being returned. One thing is that, and you will get sense of from the Facebook article, is that this data is not replicated. Okay, these all posts are not replicated to all the regions. Just for, I mean, just for redundancy purposes, you might replicate the data for one more one another region, but they are just forwarded to the other regions in a way that they are delivered to the users, but they are not persisted in that particular region. So you will not find this particular data in here. Okay, so let's say there are region 1, region 2, region 3, region 4. It is being forwarded to all the regions, but it is not saved there. Cool. Moving back to our discussion, let me quickly check if I missed anything in our discussion which I was describing. So yeah, this is the approach which we already discussed. Multi-region deployment we discussed. Okay, so I want to quickly discuss on the article which I was talking about, Facebook engineering blog. So it talks about local reads and global writes, and then global reads and local writes. And in this case, it was following global reads and local writes, which I was saying that data is persisted. The comments or like the user connections are persisted in the particular region where users are connected to, and from that region, the data is pulled off, or data is like the data is being pushed off from another region to the another region, and then there it is delivered to the all the users. It is not locally persisted to all the regions for the users to directly access it. So this is one of the thing which you will, like, if you go through, I will definitely add that link in the video description, you can definitely check that. uh cool. And yeah, so this is the end of the video, and I hope you liked it. uh you might say this is not into much of the depth, but I think you will get the high level idea of how this system works. And yeah, that's all for today. I hope to make more videos in future and stay connected with you guys. Cool, see you, bye bye.